Okay, Year 12. So what we're doing in this presentation is we're talking about composite functions and whether or not they exist, because sometimes they exist and sometimes not. Now mainly this is out of exercise 1e. Now what happens if we say f of x is equal to x plus 1 and g of x is equal to the square root of x minus 2? Does g of f of x exist? Well, we could probably say, well, all right, well, if we put in everywhere there's an f of x, x plus 1, and then we said, well, g of x plus 1, if we put that in there, we could say, well, in place of everywhere there's an x, there's now an x plus 1 minus 2, that would be. So there it is, and it exists all the time. Well, let's check this out and see whether this is true in reality. So if we said, what about g of f of x is equal to minus 7? So if we put in place of x here, minus 7, what will we get? So that would be f of, let's see, minus 7 plus 1. So that would be minus 7 plus 1 is minus 6. And if we put in minus 6 in place of g, that would be minus 6 minus another 2, which is square root of minus 8. Well, wait a moment. Square root of minus 8 doesn't exist. So we've got a bit of a problem here. We can work out the rule, but this part here is a questionable thing. So what we need to do is to put up a few rules to be able to establish whether this is true or not. Give me a second, I'll clear this up and we'll go through and do it a little bit differently. Okay, now if we want to determine whether it exists, we set up a table. And across the top we put up the domain and the range. And on the top line we put in the inside function, which is f, and on the bottom line we put on the outside function, which is g. Now if you look at this graph here, what's the domain and range? Well, there are no restrictions on the x values. We can put in any x value we like, and as a result there are no restrictions on the y values. That's a linear graph that goes from negative infinity to positive infinity. Well, what about this graph here? Well, the restriction we have on this graph here is that x must be 2 or greater, because if we put in anything less than 2, we'll get a negative square root, which doesn't exist. And what y values can come out? Well, those from 0 to infinity. Now, what we've got to ask ourselves is if this goes into this. So anything from the inside x value, if this goes into this g value, it must be able to produce a real value. Do you remember before when we put in negative 7 and nothing came out? Well, it means that this part here must be a subset of this here. Now if you look at it, this is bigger than this. So that means that the range of f is not a subset of the domain of g. And therefore g of f of x does not exist, because a value could come out from here and go into here, which would mean we got a negative square root like we did before, and we can't have that happening. So it means g of f of x does not exist. Alrighty, let's try another one. Now here's the other way around, I guess. Before we were working out g of f of x, now we're working out f of g of x. So let's set up a table like we did before, with the main and the range and the inside function g on the top line and f of x, the outside function, on the bottom line. Now, what is the domain and range for g? Well, that'd be from 2 to infinity and from 0 to infinity. And with before, there are no real restrictions on this domain. We can put in any x value we like and we'll get out any y value. Now, no matter what value we put in to g of x, we'll only get a positive answer. So that means this part here will be a subset of this. So the range of f is a subset of the domain of, the range of G is a subset of the domain of F, and therefore f of G of X exists, because no matter what values we put into G of X, we'll always get a value out of G of X where we put it into F where we can work it out. Alrighty, well I hope that helps. I'll see you in class where I'll try to answer any questions you have.